Okay, this is the part of the, today we're talking about a part of the lecture that is a part of the lecture on the measure of positions. Uh, and this part is the last part of the lecture in which we are examining the topic of box plot or a box and whisker diagram. That's how we're going to call it. And to be able to do that, you would need to have the quartiles, the first, second, and third quartile, and of course it's relatively easy to find out the minimum and maximum of the sample. So this is the basic rule how to do that. Once the data is sorted, so the data has to be sorted. Once the data is sorted, you will first determine the minimum and maximum, which is going to be easy. After that, you're going to find out the median, and which is also quartile 2, and then you're going to find out quartile 1 and quartile 3, so in that order. Now, the rule to do that is simply by finding a median the way that we have done before, which means if you have an odd number of sample items, you will find the middle value, that will be the median. If you have an even number of sample value, you will find 2 in the middle, and that average of those 2 will be median. So for example, I have here a sample of people's height, students' height, and the highest person in the sample is 85 inches tall. The shortest person in the sample is 45 inches tall. And you can see here the data is sorted in this line, in these 2 lines, and you can find that the number of things you have in the sample obviously is even. So you have the upper half between 85 and 66, and the lower half of the sample between 65 and 45. So I have 2 items that are in the middle, which would be the lowest part of the upper half, 66, and the highest part of the lower half, which is 65. The average of these 2 in the middle would be the median. So the median is 65.5. Okay. Once the median is determined, we will either throw that out of the sample if the sample has an odd number of parts, or we're just simply going to divide the sample in 2 parts, 2 equal parts, if the sample has an even number of parts. So we have even number of items. So we have here obviously 24 items, so we're going to have 2 halves, and the upper half is the upper line here, the row, and the lower row is the lower half. So I am now looking for the quartile number 1 and quartile number 3. The quartile number 1 would be just the median of the lower half. So when I look at this lower half here, those are the items from 65 to 45. I can find the 2 in the middle, 62 and 61. Again, divide this part into 2 parts, and you'll find the lowest in the upper half and the highest in the lower half, and the average of these 2 in the middle would be 61.5. That is what we call a quartile 1. So quartile 1 indicates the median of the lower half. The median of the upper half would be quartile 3, and that is of course going to be in this particular sample done by averaging 2 in the middle in the upper half. So this is 72 and 71. The average is 71.5. We also have something called interquartile range, which is the range between the quartile 1 and quartile 3, which you can find by subtracting these two. So if you subtract quartile 3, 71.5, and quartile 1, 61.5, the interquartile range is the difference, which is in this case 10. So now you have all 5 important numbers that we need for the box plot or box and whisker diagram, which is the minimum. The minimum is obviously 45, the maximum 85, and you also have first quartile 61.5, median 65.5, and the third quartile, which is 71.5. That would be enough to make a box plot. So before I do the box plot for this particular sample, I want to show you a couple of other things that might happen if you are dealing with the a different sample than the one that I have here. So I have on the board sample 1, 1, 1, 3, 3, 4, 5, 7, 8, sorted again. So I have the minimum, I have the maximum, and in this case I have 1, 2, 3, 4, 5, 6, 7, 8, 9 items. So I have the item in the middle. One of the trees is the median, so this would be the median. So I have my median, I have of course my minimum, the sample minimum, and I have the sample maximum. So the next thing would be to determine the quartile 1 and quartile 3. Okay, this is how you're gonna do that. This one will be counted out, and you have now lower half and the upper half. In the lower half you have 2 in the middle. The average of these 2 in the middle is the quartile 1. So the quartile 1 is the average of 1 and 1, which is 1. Coincidentally the same as minimum. And the upper half, you have 2 in the middle, and the average of these 2 in the middle will be a quartile 3, which is 6. Now we call this 5-point summary of the sample with the, of course I would write it in the order, so I would say the minimum, the quartile 1, the median, and quartile 3, and the maximum. So this will be 5-point summary of the sample. I write it with a dash in between, but you can as well put the commas or something else that you prefer, 3 dots or things like that. But you have to be able to distinguish that what is what. So we have minimum, quartile 1, median, quartile 3, maximum. Okay? Some of those things could be equal, but it's always in this order. Minimum cannot be bigger than anything else in the sample, it's going to be smaller than anything else in the sample, or maybe equal to quartile 1, like in this case. Quartile 1 is the next biggest thing. The next biggest thing is the, I should say the next smallest thing is quartile 1, the next smallest thing is the median, the next smallest thing is the quartile 3, and the last smallest thing or the biggest thing is the maximum. That's going to happen in this particular order. Okay, so this is the situation that we have in this particular sample. The if I don't have like item like that, then situation will slightly change. I would have the 2 equal parts of the sample. The median would be 3.5. So in this case, the median would be 3.5. The minimum is still 1. Maximum is still 8. And now I would have again the average of 2 in the middle here would be the quartile 1, which is 1, and the average of these two would be quartile 3, which is 6. So I didn't have to throw anything out in this particular case, but didn't have any middle guy. Now we could also have things like this. I'm changing my sample again to give you a different scenario. Right. So in this particular case, I have 10 items in the sample, so this is even. So I have a little bit different situation. I'm using single digit numbers, but of course if you have a double digit or triple digit, then of course you're going to try to make a distinction, so you probably use comma in between. Right, so since I have an even number of things in the sample, I have the first half, and I have the upper half, the lower half and the upper half. Obviously my minimum and maximum is still the same. I didn't change that. Now I would look for the median to be the average of 2 in the middle, because I don't have the middle element, the middle item in the sample, so median is the average of 2 in the middle, which is 3.5. Again, how do you find the average of 2 in the middle? Well, you have to divide the sample into two parts. Once it's sorted, and the highest element in the first part and the lowest element in the second part of the upper half should be the two items you're looking for, and then you make the average. Now the quartile number 1 is going to be the median of the lower half, and the median of the lower half is the central guy in the lower half, which is 2. That is a middle guy. And then you have the upper half, and in this particular case you have the middle guy 5, and that's a quartile 3. So this is the median of the lower half, this is the median of the upper half. That's how you find the quartiles. And again, in this case, the 5-point summary of the sample would be 1, 2, 3.5, 5, and 8. So again, this is to read as minimum, quartile 1, median, quartile 3, maximum, in that order. They will always be in that order. If they're not, then you made a mistake. Okay, so this is how we're gonna approach that. Now, once you determine 5-point summary of the sample, you will be looking for the some kind of unit that you can express this as a box plot. So I'm looking here at the situation that I have in this particular sample. So this particular sample, I have the all of the elements that I need for the box plot. All right. So what you see here, I can write down now on the board. I have the minimum 45, quartile 1 61.5, median 65.5, quartile 3 71.5, and the maximum 85. The biggest thing in the sample is 85. Here you can see that. Okay, now I'm gonna do that again on the board. I am going to write the 5-point summary, just copying this what I have. obviously the box plot is of interest when you're dealing with a larger sample, more data. The 5 or 10 things that I had, like in my examples, I was showing you how to find the quartiles and the median, were usually not represented by box plots. It's too small. Okay, so I have here, as I said, the height of the students in inches. I had the minimum, which was 45. I had the quartile 1, which was 61.5. I had the median, and that was the 65. I had the 65.5, and I had quartile 3, 71.5, and the maximum was 85. So this is 5-point summary of the sample. I'm going to repeat this one more time. 5-point summary of the sample is minimum quartile 1, median quartile 3, maximum, written in some kind of fashion that you could recognize them, like here, or maybe using commas. Okay, so now box plot is a typical thing that we do very often in statistics, and obviously had to be done with emphasis on proportions. So you need to have some kind of units that you're going to be careful about putting in some proportions. So I have the data that is from the minimum of 45 to the maximum of 85. So I want to start with 40, and then I would have 10 here to be 50, another 10 to be 60. Try to be careful so this is the same 10 in the both line segment. I have 70, I would have 80, and I would have 90. And I don't need to go any further. Of course, you can write from 0 to 100, but there is no need for that. So now, this is how the box plot is going to look like. You have to find the 45, which is just in the middle here, and this is where the what we call a tail of the box plot starts. Then you are going to find the 61.5, which will be approximately here. This is where the box will start. Then we have the median, which is 65.5, so it'll be like here. This is the median that is a vertical line in a box. So this is going to be a box, going to continue. The next thing you'll find is a quartile 3, which is 71.5, something like here. So this is the place when the line where the box will end, and you're going to find the 85, which is where the tail, the right tail of the box will end. So you get something like this, and this is called a box plot. Okay, sometimes you will see that box to be a little smaller, not so wide as I have. Sometimes you can see the tails to be just very light, like small. On the other hand, you can also see sometimes they're as big as the box or as wide as the box. So it's that is all a graphical element, so it doesn't make any difference in terms of a proportional presentation of the data, because the story that goes that what is important is actually the proportion of those 5 numbers. So here you go, it's 45. Here we go with 61.5. This is 65.5. This is usually not written, but you could write. And you have 85. So you need to notice that in here we have the range of 45 to 61.5, which is 16.5. Well, all of that is just 10, between 71.5 and 61.5. It's only 10. So this must be proportionally smaller, significantly smaller than this, or shorter. So this is 16.5 and this is 10, so this must be 65% more than what this is. Okay. Also, you notice here that the difference between the first quartile and the median is only 4. Okay, between 61.5 and 65.5, you subtract, you will see that's 4. The difference between the median and the quartile 3 is actually 6. So this part must be longer than this part, bigger, because this represents a range of 4 and this represents a range of 6. Okay, this ought to be also nicely done as a line rather than some kind of curve. Then you have this part which is between 71.5 and 85, which is 13.5. So now 13.5 must be shorter than 16.5. This is 16.5, this is 13.5. So just subtract the two numbers. So that's the proportion you need to have in your box plot. Now, of course, if you do it with a computer, it's going to look a lot better than what I did. More precise, I'm sure. You can certainly use the ruler to get this nicer. Okay? So that's what is called a box plot. Sometimes this could be upside down, like it would go 45 here, and 61.5, 65.5, 71.5, and then 85. That's a vertical position of a box plot, which is perfectly okay, and it's actually very often used. And depends on the software that you use or what presentation you're making, you might want to do that one way or the other. I'm using a horizontal position, so my box plot is in a horizontal position, so the line. Okay, couple of things that you should not be doing in a box plot. It's not customary, it's not something we do, which is people do very often things like that. So now you get some kind of fishbone here. That is not a box plot, so there's no any line that goes through here in the middle. Okay, so do not do that. Also, sometimes people forget to put this line, which symbolizes the line segment, symbolizes the position of median. That should not be done because it's not just a box, but a box with the line in somewhere inside the box, which should be the median, where the median is. You could possibly color that. That's also fine if you're making something very graphical. You can do that certainly. Okay. So now I want to point out, where do you see this interquartile range? Interquartile range is this range between 61.5 and 71.5, which is this is not a part of a box plot. I'm just indicating this is interquartile range of 10. That's the interquartile range of 10 here. Right here. Quartile 1, quartile 3, this is 10. The idea of the quartiles is that first quartile divides the sample into 25-75%. The median divides sample into 50% and 50%. The quartile 3 divides sample into 75% and 25%. So what is below is 75% of the sample, what is above is 25% of the sample. That's the idea. And of course the maximum is bigger than anything else in the sample. So what we have here is, this is up to quartile 1, we have a 25%. After the quartile 3, we have a 25%, and before the quartile 3, we have a 75%, which makes this a range of 50% of the items in the sample. So the interquartile range is the range of the middle 50% of the sample. Okay, I'm not saying that things have to bunch up in this range. No, that's a different thing. But the fact is that if you're doing that properly, if you're calculating properly, the interquartile range indicates where is your central 50% of the items in the sample. That's the idea of interquartile range. Okay, now if we go back to the story of this example, one of the things that you could ask when you look at the sample itself is what are the outliers in the sample. Right. So the outliers. Well, given the sorted sample, because if the sample is not sorted, the outliers are really difficult to find. But given the sorted sample that we have here, which is the second list of the items, you could say that maybe 85 is an outlier and maybe 45 is an outlier, or maybe just an 85 would be an outlier. But that's your own perception. So what I have here is a student who is 85 inches tall. And a student who is 85 inches tall is obviously 10 inches taller than the second tallest student in the class, which is 75, right? So you have these 85, and then you have a 75. It's a 10 inches difference. So the student who is 85 inches tall is 10 inches taller than anybody else in the class. And on the other hand, you have a person that is 45 inches tall, which is 5 inches shorter than anybody else in the class. So maybe these two are outliers. So again, this is your perception. Okay. Now I'm going to tell you what exactly precise definition of of outliers is. You have to use interquartile range, and this is the idea. If something falls beyond quartile 3 further than 150% of the interquartile range, which is 1.5, that is considered to be an outlier. If something falls below quartile 1, 1.5 of the interquartile range further below, which is the same as 150% of the interquartile range, that would also be an outlier. So we're looking for an outlier that are far away from quartile 1 and quartile 3 in terms of interquartile range. Okay, so let me do this calculation in regard to this sample. So in this sample we have the 5-point summary and the interquartile range that is between 61.5 and 71.5. So I'm trying to determine what the outlier would be. So this is the rule. Okay, the outlier above would be anything that passes quartile 3 plus 1.5 of the interquartile range. Okay? The outliers below, on the lower end of the sample, is anything that is below quartile 1 minus 1.5 times interquartile range. Again, so this number is 1.5 interquartile range above the quartile 3. See, I was adding the number to it, right? This number here is 1.5 of interquartile range below quartile number 1, because I was subtracting that. This is what the outliers are. So in our particular case, we are dealing with the numbers that are quartile 3 is 71.5 plus 1.5 times interquartile range is 10, the difference between the quartile 1 and quartile 3. Now, this is 15, and when you add 15 to 71.5, you end up with 86.5. Okay? Now this calculation here will be, in our case, quartile 1 is 61.5. I have to subtract the same number here. This is the same number in both expression here, right? 1.5 times 10. And again, this is 15. And if I'm subtracting 15 from 61.5, I'm going to get 46.5. These are the boundaries for the outliers. The boundaries for the outliers. Okay? Now, if you look back in our sample, you will see that there is nothing in the sample that is above the upper bound for the outliers, because the upper bound for the outliers are just determined to be 86.5. So 85 is not an outlier. So you might have this perception that this person who is 10 inches taller than anybody else in the sample doesn't fit our definition of outliers. So this is not an outlier. Again, we have a strict definition of what an outlier means, quantitative definition, and this item 85 does not meet that standard. It is not above 86.5. Outlier has to be above 86.5. When you look at the 45, 45 is an outlier, because the outlier in a sample is going to be also anything that is below this number, which is 46.5, and 45 is less than 46.5, and that is the only item in the whole sample that meets our definition of outlier. So again, we have one outlier, and that is 45. In our sample, that is one outlier. How many outliers sample can have? Well, that depends. It could be many of them. It could be something that is outlier on either side. Sometimes that is outlier only on one side, like 45 in our case here. But those are the situations. So we could have more than one. In our case, we have only one outlier. Okay, when you are making a box and whisker diagram with an outlier, you will place the position of the tail in the smallest item in the sample that is not an outlier, and the largest item in the sample that is not an outlier, which means you will ignore outliers and you will make the box plot with the rest of the sample. You will still use the same 5-point summary, which means the minimum and maximum, which in this case could be outlier, are going to be indicated differently. So they're not going to be indicated with the tail. They will be indicated with a dot. Okay, I'll show you that in a moment how it's done with the Texas Instrument calculator. Okay, I'm not going to ask you to do that in the test, but that's what is usually done. So sometimes outliers are indicated on a calculator. Oh, excuse me, on a box plot, which I'm going to do with the calculator. All right. So let's try to do something like that. So I want to use the Texas Instrument calculator, which is going to find the outlier for me the same way I was just doing by using my own calculation manually. Okay. Now, first thing you need to do is to put the data in the calculator. So the data will be in the calculator, and I'm going to put it in one of those lists. All of my lists are clear, so I'm going to have to put the data that I just have here. So you press statistic button, which will give you the three options: edit, calculate, and test. You will use the edit option to put the things in the calculator, in the memory of the calculator. So I have 65 72, 68, 64, 60. Always start to be very careful how you put the data, because that could be a place when you can make a mistake. 55, 73, 71, 52, 63, 61, 74. That's the first half. I should say the first row, because I don't have my data sorted, and I have so far 12 items. You can see that in my calculator the next one would be the 13 item in the list 1. This is the symbolically written here, list 1, the 13th item. So that will be 69. This is the 13 item, right? Then 65, 74, 50, 45, and I have 75, 67, 62, 66, 85, 64, 65. Okay, 24 items in the sample. I just put all of these guys in the calculator, in the memory of the calculator. Now, the first thing you want to do, I guess, would be to sort this, because you want to see what the minimum and maximum is. You really don't have to do that, because I'm going to show you in a moment the calculator can do that, can do all of the calculation of 5-point summary without you sorting the data. But for the purpose of checking out that this is exactly what we have here, I'm going to sort it. So sorting data is again the bottom statistics. You will select now in the edit option sort if you want to sort in ascending order or if you want to sort in descending order. So since you can see that in my story here I have sorted that in descending order, so I'm going to use descending order this time. You have to also write what are you sorting. So I am sorting list 1, which is second option 1 here. You can see the blue option here is L1, so you have to press second option to get this blue option. And of course there is a green option, but we're not using that. So blue option is L1 here. Close the parentheses, or if you want to sort multiple lists, put a comma, put a list 2, list 3, whatever you have, list 2, comma, list 3, and so on. But eventually you have to close the parentheses, and you press enter, and your calculator will report to you the data has been sorted, which you can check by pressing statistics again. Press edit, and you can see here now the data is sorted the same way I have it in the paper here. 85, 75, 74, and on. Okay, and the smallest item in the sample is number 24, and that is exactly 45. I don't have anything else there. Okay, now if I want to use a calculator to find a 5-point summary, I would press statistics, and I would go for an option calculate, and just like the way we were calculating standard deviation and the mean, you would use the option one variable statistics, the mean, the standard deviation, the 5-point summary, the median, all of that are statistics of the sample. So this is one variable statistics. The one variable we have here in this sample is the height of students in inches, the height of a random student in inches. So that is our variable. So it's only one variable. We don't have anything else. Now Sometimes you need the two variable statistics in case you are using maybe a height and weight, but we don't have that here. So one variable statistics, and we are calculating. The question is where the data is. The frequency list 1. Excuse me, the list 1. The frequency list is by default, everything is counted once. So I said it already before, if you have the data that is like maybe 85 is 3 times, 75 is 7 times, 74 is 2 times, and on you go. You just write every item once, and then in the next list in the same row you write how many times that thing is. In which case you would use a frequency list. You would have here something, maybe L2 or whatever the list that is that contains frequency. I don't need that here. I wrote everything once. There are some pieces of data like 74 you can see here twice, and 64 twice, and so on, but that's just I put that all in. So now you calculate. So you move arrow down and then press enter. All of this stuff is already we are familiar with. So this is the mean, the sum of x's, the sum of x squares, the sample standard deviation, population standard deviation, because your calculator doesn't know whether this is a sample or a population, so it does both. The items that you have is 24, and now the 5-point summary is right here. So 5-point summary is 45 for the minimum, quartile 1 61.5, median 65, quartile 3 71.5, and maximum 85. That's a 5-point summary, the same one we have. Okay, it doesn't tell you what the interquartile range is, but you can find it yourself by subtracting quartile 3 minus quartile 1. You can also plot this data. So I said I plotted on the board. Calculator is going to do that more precisely, maybe the better proportion, I believe. So calculate by using statistical graphing, by using statistical plot is going to be a second option here on the very top left of your calculator. So it says stat plot. Okay, so again you have to select, this is blue option, so you have to select blue here, second option, and you're going to press this button, and you have now a number of plots that you could do. You have to turn at least one of them on that you're gonna use. They're by default all of them off, 3 of them actually. You have a couple of other options here. It says you can turn them all off or you can turn them all on, but I'm just gonna turn the first one on. So the first thing you have to do when you enter the plot, you have to turn it on. Again, use the arrows to move the options. So now I'm going down, and you can see here the box plot is here and here. Okay, now this is the box plot with outliers dimension, and this is just the box plot. So let's do first just the box plot. They put them in a strange order though. The X list is where your data is. You can have another list. I'm not going to have another list, so I'm okay with my X list, my X data to be in the list 1. I don't have another list. You can leave this the way it is, or you can clear it. I think you can clear it, right? Oh, doesn't allow me to move any further, so I need to leave it the way it is. So L2. Okay, so now I have the mark I'm gonna use. This mark is only for the outliers, but since I'm not, okay, I didn't change my type of a plot, I notice here. So this is the little problem that I noticed. Okay, let me go again. I need the box plot here. That's why I have this problem, right? Here you go. All right, now I don't have any further problem. So I have a list 1 only for the X, no any problem with any other list. I have a frequency list. Now you can put here list 2 if the frequencies are list 2, or you can just keep it by default here, which is 1. That means that every item in your sample is 1s. And also it offers you the different color that you could use for your box plot. My box plot on the board was just black and white. Let's use red just for fun. Okay, I have to use the arrow here. I'm used to working on computers, so I thought I can maybe do it on calculator, but of course the calculator doesn't have a reactive screen. So let's use red. So and then obviously the next thing you want to do is to plot, and you remember that the Greek word for plotting is graphing. So that graph here ought to be pressed. And all of a sudden you find yourself, well, I don't have anything here, right? Now here is the story. Your data is between 45 and 85, and not your axis. But notice here, this is the good old coordinate system, which is having a zero here. So you go from -10 to +10 for the axis, from -10 to +10 for the y. Your data is nowhere here because your data starts with 45 and ends up with 85. So when I was graphing my box plot, I was using the scale from 40 to 90. That's what we're going to do. So we will select our window differently than what we see here. So you have to use the option window. And I'm going to use X minimum to be 40. That's the smallest thing I use on my scale. You can start with 45, but you won't see the tail because it will be right at the edge. So I'm going to use 40. And the maximum I use in my scale, when I was graphing that myself, I was plotting it on the whiteboard, I have 90. The scale for the X, this is just to put up those notches on the scale, which could be something that you might want to have, or you might have it less pronounced. So I don't want to have that by 1, because then I would have 50 of them going from 40 to 90. So I'm going to use 5. It sounds like a good thing to use. Then you can use the y minimum, y maximum. Notice I don't have any y data here, so I could use this as a default, but a little bit problem is going to be that if I use a default, which is going to be between -10 and 10, I will have this x-axis line, the x coordinate axis line right in the middle of my graph. So I don't want that. So I'm going to use y minimum to be 0. And the y maximum can stay 10. Y scale, not important. You can use anything you like. Resolution, I don't care about that. And this is something about the tracing and how quickly you can move the arrows and things like that. I'm going to leave that the way the calculator says it should be. I'm not at all concerned about that. And now you can go back to graphing, the plotting, and now you have your nice box plot, nicer than the one that I made. This one has all of the features you need. If you need to read the 5-point summary, you will place the tracing, and you can see the tracing is one of the top buttons here. So said you can also zoom. So you can zoom, you can adjust the window, you can write what you need to plot, you can trace, and you can graph. So if you trace, the first thing is going to show to you is the median, which is interesting. So the median is 65. It should be 65.5. So we'll check that out. The 61.5 is a quartile 1. The minimum is 45. And if you go to the right, 71.5 is the quartile 3, and 85 is the quartile, another quartile, the maximum. So let me check it out what is wrong with the median. So I should have a median 65.5. So maybe I have some wrong input. If I go back to test statistics, this could easily happen. And I press edit, and I can read my data just like I have here, sorted. I'm supposed to have a 66 and 65 to be 12 and 13. So that's probably a mistake. All right, so I have number 12 is 65. Oh, okay, so that's a mistake here because I put a wrong input apparently. So it's 66, 65, 65, 65. In my sample I actually have 2 times 66. Oh no, 66, 65, 65. So but looks like something has been missed before. So we have 66, 11, 65, 12. Now in my sort here I have 66 to be E12 and 65 to be 13, while 11 is 67. So we have wrong input somewhere. Okay, so I can go back again piece by piece. I have 85, 75, 74 twice, 73, 72, 71, 69, 68, 67, 66. Okay, so 167 is missing. In my sample I have them 2. You see the original sample, there is 167 and there is another one here. So that's a mistake. Mistake on my input, right? So I got something wrong, so we're going to change that. So we have a 67 here, there are 2 67, and then we have a 66, and then we have a 65 twice, and that's perfectly okay. So we have 65 twice, and the rest of that is fine. Okay. So one mistake. Instead of having 267 and 166, I somehow put in the when I was putting the data in, I put in 167 and 266. Now, okay, I didn't intend to have a mistake like that, but it shows you that you have to be very careful with the input, because this is the place you can make a mistake, and computers will not make a mistake. So you have to be careful. All right. So if I go back again to my plot, my graph, now it's going to be, I believe, okay. If I trace, the first thing I get is the median, which is 65.5. This is exactly what we have. And everything else stays the same. So it's the quartile 1, 61.5, the minimum is 45. Here it's on the bottom is written what it is. Red color is somewhat annoying, right? Maybe I should have used blue. And the 71.5 and the maximum is 85. Everything else is fine. You can also zoom. All right. Oh, it gives you lots of options. Zoom in. Oh, doesn't change anything. All right. In either case, I'm not really interested in zooming. The screen is relatively small, so you can't really get anything great here. Maybe I could increase the whole thing. Not really. All right. I don't have enough space to increase this. All right. So what about the outliers? Okay. So our calculation shows up that 45, the data item 45 in the sample is an outlier. So you can get it from your calculator by using a box plot option. So again, statistical plot is the blue option here. And this time I'm going to use the the fourth option here. This is the box plot with outliers. I am not going to do any other change. It's proposing me that I could mark outlier by the little open square or a cross or a dot. I think I'm going to keep the little open square. And then I want to change the color now. I want to use like blue is just fine, right? Or light blue, maybe just navy blue. All right, so now I'm ready to graph. Everything else is nicely already selected. You have to make sure that the window is right? But I'm keeping the window as before, and now I'm graphing. You see what happens. So what you have here, I'm gonna trace now, is it's telling you that sample starts, tracing starts differently. The sample starts, if you don't count an outlier, at 50, which is the sample without, the minimum of the sample without outlier. The outlier, but it doesn't have any special mark for that. It says X is 50. It doesn't tell you this is a minimum because it isn't. The minimum is still the outlier. The outlier is still the part of the sample. It's just not a part of this box plot anymore. The tail is now at the item in the sample that is not an outlier. But the rest of that is the same because we have still the quartile 1, the median, the quartile 3, and the maximum calculated the same way as before. So finding an outlier didn't change anything else in the sample. The only thing that have changed here in terms of a box plot is that we are marking the outlier specially, maybe with a cross or open rectangle, and the tail, the lower tail in this case, starts where the item in the sample is not an outlier, which is 50. Now if you have two outliers, you might have two dots here or two rectangles before you start with the tail. If it's on the lower end, it could be also something on the upper end. It should be possibly another outlier. Okay, so that's my story about the graphical presentation by using the box plot and the box plot with outliers. So remember that this is a very specific way how we determine what an outlier is. It's not a perception, so it's not, well, do I feel good about it, or that this thing looks like something that doesn't belong to the sample, or it's very different than the rest of the sample. No, we are not doing that way. We are using a particular formula, like you see on the board, that I use to determine the outlier. Right? Anything above quartile 3 plus 1.5 times the interquartile range, and anything below quartile 1 minus 1.5 times the interquartile range. Those items in the sample that satisfy that criteria, being above the 86.5 or being, in this particular sample, being below 46.5, would be deemed outliers. Okay, that's my story to complete this lecture. I hope this is easy for you to understand, and you should probably use some of the samples that we had the previously to create the box plot yourself. We had that luggage on Hawaii airport. You can try to do that and check the outliers there. And NFL players age, we had that too. And again, you can use a calculator the same way. Practice that a little bit to get the idea. And I also have some other questions here about what a percentile, some pieces of data are, to give you an idea about calculating percentile like we did in the class, right? So I'll see you on our test pretty soon, I think. Okay? Thank you for watching.